Hello friends, welcome to Electropixels. This is a Panasonic 43-inch LED TV. The complaint is no picture that comes to repair. Whenever we power on the TV, the picture comes for a second and goes dark. The picture will fade when we power on the TV. Then it will become no picture. This is the T-con board. It's an LG panel. Here the picture comes while we power on and the picture will fade within a seconds. Here you can see while power on the picture comes and the picture goes fade and suddenly it becomes dark. So the picture goes and only backlight. Here you can see only backlight and the picture suddenly fades. Whenever we power on the TV, the display comes at first. Then the picture will be there in few seconds and it suddenly goes fade. At that time the backlight is okay, but the picture goes dark. Here we turn off the TV and again turn on the TV. You can see once again the picture comes and the picture stable for a second. And after that the picture goes dark and the display fades. So this is the T-con board. As I said here, it is a LG panel. This is the motherboard of Panasonic. This is the inverter board and this is the power supply board. Before start repairing, now let's again check the TV and check the complaint again. Confirm the complaint again. Here while powering on, here you can clearly see the picture comes and the picture goes fade. You can clearly watch and become no picture. Power on again, power off the TV and power on the TV again. Now the TV is power on again. You can see the picture comes at the initial startup and the picture goes fade and became no picture. Now let's start the repair. Here you can see before starting now let's see basic panel voltages. The basic we have to first check the initial panel voltage 12 volt is present or not, panel VCC. First we need to check the panel VCC voltage. The panel VCC is 12 volt. We need to check the voltage using a multimeter. Here you can see that panel voltage 12 volt is okay. So the panel voltage 12 volt VCC is present. Now this is the VGH point. Here you can see the VGH point. Now let's check the VGH voltage is present or not. Here you can see that the VGH voltage is missing. Now let's check the VGL voltage. This is the VGL point. This is the you can see that VGL voltages are also missing. So the VGH and VGL are the basic panel voltage. So these two major voltages are missing. Here we can see the both VGH and VGL is missing. This is because of the internal shorting in panel left side or right side. So here the gate signals are short in the panel either left side or the right side. So we need to remove the each side FFC cable and check the voltage again. If the voltage comes here we first remove the right side FFC cable. The FFC cable is removed. Now let's check whether the voltage is present or not. While removing the right side FFC cable, Here we can see that the VGH voltage is present. Both VGH and VGL voltages are present now. While removing the FFC cable, both VGH and VGL voltages are present. This means that the problem is with the right side FFC, right side gate signal. So the right side gate signal is short. Due to that, this complaint occurs. While removing the right side FFC cable, the VGH and VGL voltages comes again. So we need to block the gate signals entering to the panel from the T-cone. Here you can see all voltages are present. So the problem is confirmed with the right side. So we need to block the gate signals entering into the panel. For that we need to block the first 13 pins from the T-cone. We need to block the first 13 pins entering to the panel. Starting is from the T-cone. The signals are to be blocked from entering into the panel. These are the points as I marked in meter point. You have to block these 13 signals entering to the panel. Here we take a cello tape for blocking the signals. Here we take a cello tape and cut out the cello tapes to block the first 13 pins signals. Using this cello tape, we masked the cello tape for blocking the signals, gate signals entering from the panel. Now with this cello tape, the gate signals are blocked and prevented from entering into the panel. Now the tape is applied. Now let's connect the FFC cable back to T-cone and check the voltages. Here we properly connected the FFC cable back to the T-cone. You can see that one side you can see that the cello tape is there. Tape is there at the end. Now we successfully blocked the 13 signals and gate signals entering to the panel through the T-cone. Now let's check the voltages to confirm whether the shorting is removed or not. We can see the VGH voltage is there, 28 voltage is there, is present. Let's check the VGL. The VGL voltage is minus 4.9 volt is also there. After masking gate signals in right side, all voltages are okay now. Now all voltages are present. So now let's check the TV display. Here you can see that the TV display is okay now. Now the picture is perfectly alright. The picture is steady. There is no fading. You can see the picture is perfectly alright. Now the complaints are solved and the picture is okay now. We want to test it for 1 hour for checking any other complaints. You can see now at this time the picture is okay. Picture doesn't goes fade. The picture is steady. Now the complaint is rectified. The complaint is with the right side gate signal is short in the panel. That is causing this is the reason for this complaint. We have checked the TV for 1 hour and the TV is perfectly alright now. The complaint is 100% solved and the TV works well. The display is completely back to normal. Picture is steady and doesn't go fade now. Now display is perfectly normal and picture is perfect now. Thanks for watching.